In 2015, we left the rat race and went to the farm. We bought a 100-year-old farmhouse and 9 acres. After 3 years of extensive renovations, we can finally call ourselves College Hill Farm. Welcome back to College Hill Farm. Today, we're talking about interpreting a simple soil test. Today, I'm going to talk about how to interpret a simple soil test. Now, as far as the soil tests go, the soil tests that are run by your Cooperative Extension Agency are way more comprehensive than the simple soil test that I showed you earlier. Some folks have fussed at what I had to say about soil tests being necessary and not necessary. I'll put it to you this way. For probably 20-25 years, we gardened without a soil test. My grandfather, I don't know that he ever did a soil test. My father, mother, I don't know that they ever did a soil test. But for 30 years, we put 80 to 90% of the food on our table. So, are soil tests necessary? Yeah, they can help you identify some problems. But to be honest, a soil test is not 100% necessary. If you pay attention to your garden, to your plants, you'll see symptoms that they might lack a mineral or need this mineral. You can figure it out. But anyhow, let's go on with that. Enough about that. We're talking about interpreting a soil test. Now, what I'm going to do about it. So, just for the record, some folks said that I didn't leave my soil to settle long enough. If you'll look today, this is 5 days later, it's still just as cloudy as the day I tested it. I would say that this soil would take months to clear. So I did the test at the right time. Alright, so to go on, I'm going to show you what my soil test came out. But what you're going to need to do, you're going to need a calculator. Well, I'm going to just use the calculator on my phone because you don't need a scientific calculator. If it just adds, subtracts, multiplies, and divides, I'm going to show you what to do. What I'm going to do. What you do is totally up to you. Some people do raised beds. Some people do hugel cultures. Some people do a whole lot of different things. Back to Eden. All those different type of gardening techniques. I do wide row and standard row crop gardening. Okay, it's what I've done since I was a kid, and it's what I'll continue to do. That doesn't mean that I haven't tried raised bed gardening or multi-cropping or all these other things. I've just found that they were a lot more work and put less food on my table than the methods that I use. So you'll see me over the year. You'll see what I do. I do row crop, wide row, and then standard row crop type stuff. So you'll see how we do that. So I'm going to try and make the camera to where it will focus on a page. So you're not going to see me. You might hear me talking, but you're probably not going to see me for most of this video. We're just going to talk about the garden, the results, and what I'm going to do about it. So let's go ahead and get to looking at the paper. I hope you can see these papers. Of course, I know that some of these may not be that clear on the camera. The paper that you're looking at right now is going to show you what I'm going to do in my individual garden as far as fertilization goes. But first off, you'll find this paper that I'm showing right here. You'll find this paper on our Facebook website, on our Facebook site, as a picture so that you can look at it and refer to it later. I will go ahead and upload that, and I will also put a link in the comment section about this, and it's a 2-page thing. It tells about each type of plant that we're going to use, whether it's potatoes or carrots or cauliflower or eggplant. Okay, it's going to tell you about what we're going to do. So let's look at what my garden did. All right, you can look and see how our garden did. Each garden has its own thing. And the garden falls between a 5.5 pH and a 7.0, 6.8, thereabouts. So that's right in the range that all your garden plants are going to be just fine. So I'm not really concerned about pH and raising the pH. So we can go on from there. My nitrogen was N0. And in other words, meaning nitrogen was depleted. Now, this is exactly what I anticipated this was going to be. This was a central Kentucky field that had been used for hay for years and years and years. So you can figure that the nitrogen 4 inches down is going to be depleted. Okay? Potassium was somewhere between sufficient and decreased, and then or phosphorus, and then potassium was decreased. So I need to add potassium and phosphorus both. So that really makes it really simple for what I'm going to do. Now, a more expensive test, you could get trace minerals. You'd find out iron and magnesium and copper and all of these other trace minerals. But I'm not too worried about that right now. So this is going to allow me to figure out what it is that I'm going to do. So I need to concentrate on N, P, and K. Well, really, since my P and K are already pretty close, most of the fertilizers that you buy already have P and K in them. So since they're pretty close, adding a little more is not going to hurt nothing. So really what I need to focus on is nitrogen. So let's take a look at that. First off, let's talk about a bag of fertilizer. Okay? Let's say we've got a bag of fertilizer. And that fertilizer is called 10, 10, 10. Okay? Now what that means, nitrogen, potassium, and phosphorus. And I'm not certain if that's the right order. It might be nitrogen, phosphorus, potassium, but I'm not really worried about these two on mine. You can worry about that, but it works out the same way you do nitrogen. So let's talk about nitrogen. Let's say you buy a 40-pound bag. Let's say you buy a 40-pound bag of 10, 10, 10 fertilizer. What that means is that 10% of that bag, or 4 pounds, out of that bag is nitrogen. Okay? Does that make sense? You buy a 40-pound bag, 10% of it is nitrogen. Or in other words, 40 times 0.10 equals 4. So you got 4 pounds of nitrogen. So then we want to look around and go, okay, so I've got 4 pounds of nitrogen. So how many ounces of nitrogen is that? Well, how many ounces are in a pound? There's 16. So it's 4 times 16 equals, if you do that out, it's going to be 64. It's going to be 64 ounces of nitrogen is in that whole bag of fertilizer. Now, that may not seem like a lot, but it's quite a bit. Now, let's say we're going to refer to this this sheet right here. Let's say we're going to do I don't know, let's pick one. Why don't we say cabbage? It says here that cabbage you side dress with 2.5 ounces of nitrogen per 100-foot row. 2.5 cabbage, 2.5 ounces in a 100 per 100 feet row. Now I plant my cabbage about 2 feet apart. So that means in order to do this, I need I've got 50 cabbages. Or thereabout, 48 or 50, in a 100-foot row. So I need 2.5 ounces of fertilizer to fertilize those cabbages. So now, how do I figure out how to get 2.5 ounces? Well, in this 40-pound thing, there's 64 ounces. So 40 pounds, there's 64 ounces per 40 pounds. Or in other words, you divide that out. 64 divided by 40. I'm sorry that there's math involved, but just the way it is. 64 divided by 40 equals 1.6 ounces per pound. Okay? So I need 2.5 ounces. Well, I'm not going to be crazy. Okay? I'm not going to be crazy. So I'm just going to take 2.5 ounces. I'm just going to double that. And I'm going to say I need 2 pounds of fertilizer for those 50 cabbages. And you can figure out how to divide out that 2 pounds of fertilizer. You put it in a container, 2 pounds, and you can figure out how to divide it out among your 50 cabbages. That's what I'm going to do. Let's do another example. How about tomatoes? Okay, tomatoes. My little paper that I've made for y'all says 1.6 ounces of nitrogen in a 100-foot row. Let's get another piece of paper and put down here tomatoes. So I need 1.6 ounces of nitrogen per 100 feet. Well, again, I plant my tomatoes about 3 feet apart. Okay, between 2 and 3 feet apart. So if I do that, I get about 35 tomatoes in a row. So that's 35 tomato plants. In a 100-foot row. And I need 1.6 ounces. Well, all I have to do is come back to my thing here. You will notice that in 64, if we divided out the 10-10-10 fertilizer, there's 1.6 ounces of fertilizer per pound. So I only need 1 pound. It's real commonsensical. Okay? Now, but then it says on these tomatoes, it says you work that into the soil at planting. Then side dress with another 1.6 ounces when fruit are about 1/3 grown. After picking the first ripe fruit, side dress with another 1.6 ounces. In other words, I'm going to use a pound of fertilizer for 35 tomato plants, and then I'm going to use a pound again and a pound again. A pound of fertilizer is not a lot. Okay? So, tomatoes are not as heavy a feeder as one might think. And you can use some things like Miracle Grow and things like that to really boost the amount of nitrogen to very begin with and make that different. So, that's how I'm going to address my garden. How you address yours is your business, but that's how I'm going to address mine. And I hope that this has helped you. But before we go on, if you've got 12, 12, 12, well, you just multiply the weight of the bag times 0.12, and that tells you how much nitrogen there is in that bag total. So it's 40 times 0.12 equals, that bag has 4.8 pounds of nitrogen. Then 4.8 times 16, 4.8 times 16 equals, 4.8 times 16 equals 76.4.8 ounces. Then you divide that by how much there was, 76.8, divided by 40. For every pound, divided by 40. For every pound, that's 1.92 ounces of nitrogen. For every pound of fertilizer, it has 1.92 ounces if it's 12, 12, 12. Same way if it was 34, 0, 0. Okay, if it's less, like some lawn fertilizers are 34, 0, 0, so it would be 40, the weight of the bag, times 0.34 equals 40 times 0.34 equals 13.6 pounds. 13.6 pounds in that bag, divided or times 16. 13.6 times 16 equals 217 ounces of nitrogen in that bag. I hope that helps. You can use, I've given you this in this way because what I've done is I went ahead and wrote out for each individual crop in ounces of nitrogen per 100 foot row. And in case you wonder why I do that, remember all my rows are 100 foot. That's our video on what we're going to do when we apply our fertilizer. Now, it's okay if you don't agree with the way I garden. That's fine. Everybody's going to garden in their own way. If you want to use an organic blood meal, you know, on the bag it tells you the percentage. You can still use these numbers, okay, to help you determine. You can still use this to help you determine how much nitrogen you need. So if you want to use an organic thing, that's fine. If you want to garden in a totally different way, that's fine. I've been doing this for about 47 years, been very successful. 80-90% of our food we grow right here on the farm. Am I 100% sustainable? No. I don't know if I'll ever get to be 100% sustainable. I don't know if you can ever be 100% self-sustaining. Okay? I hope to get as close as I can get. We're going to get animals and other things. But now if you like this kind of stuff, we're going to show you over the course of the year how to grow your own food. How to produce 80 to 90% of what you need to sustain yourself for the year. We're going to teach you how to do that. I'm going to teach you how I do it, not necessarily how anybody else does it. Like I said, I've been doing this for 47 years, and we've been fairly successful. So if you like it, subscribe, hit that little bell up there, and it will notify you when the videos come out. I try and upload videos every Sunday. Over the winter, I generally upload one video a week. But over the summer, it'll be 2, 3, 4 videos every week. So just give us a subscribe, give us a thumbs up every now and then, even give us a thumbs down. That's okay too. It's all just feedback. If you don't like what we're doing, hit the don't like button. That's fine with me. Just let us know, and it's time for me to get on to the next thing.